this is a review of trigonometry, and so we know that if we have two right triangles that have the same reference angle, that those two right triangles are similar by angle, and therefore the ratios will be equivalent for each of those triangles for any of the three side lengths. So because of that, we have named those three ratios sine, cosine, and tangent. So we always need to make sure that we are taking sine of some angle A, and that angle A is our reference angle. And then when we look at our reference angle, we are going to then label the sides as opposite, hypotenuse, or adjacent. Hypotenuse is not going to change no matter what our reference angle is, because that's always the side that is across from the 90-degree angle. But then, based on our reference angle, the opposite leg has to be the leg that is across from that reference angle. It's the leg that doesn't help make the angle, right? It doesn't touch the angle. It's opposite it. And then adjacent means next to. And so that's the side that helps create the reference angle, but it's the side that's not the hypotenuse. So when we look at our reference angle A, and we want to come up with our ratio, sine of the reference angle A, it is the opposite side length over the hypotenuse side length. And so that ratio for any right triangle that has the same reference angle A will have the same ratio of the opposite side to the hypotenuse side. Then we have cosine, which is the adjacent side divided by the hypotenuse. And again, any right triangle that has reference angle A will have the same ratio of adjacent side to hypotenuse side. And then we have tangent, which is opposite side over adjacent side. And so one handy way that people like to remember these is by using this little shortcut, SOHCAHTOA. And so that just is a little helpful tool. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. SOHCAHTOA. Now let's say that our triangle, that same triangle we have with angle A, let's say now B is going to be our reference angle. If we were going to do sine of B, our opposite side is now this side right here, because that's the side that's opposite of side B. And our adjacent side is now this side right here. Our hypotenuse didn't change because, again, that's always the side that is across from the right angle. So how can we use this to help us? Well, for now, let's just focus on finding these ratios. So this problem asks us to find tangent of C. So I'm going to go ahead and circle my reference angle. There's my reference angle C. And so I know that tangent is equal to the opposite side over the adjacent side. So I need to go ahead and figure out what that is. So opposite my reference angle C is this side right here, which is a length 10. And then I know that this side here is my hypotenuse. So that makes my adjacent side this side right here, which is 24. So my tangent of C is going to be 10 over 24, which we can reduce to 5 over 12. And so that is my ratio tangent of C. So if we look at a similar problem, but this one asks us to find cosine of z. So I'm going to go ahead and again just circle my reference angle. So cosine is going to be adjacent over hypotenuse. So I need to make sure I figure out which side is adjacent. So I know that the side that's across from the right angle is the hypotenuse. So that makes my hypotenuse 29. And then adjacent means next to, so that's the other side that is next to my angle Z. So that's 20. That's my adjacent side. And 20 over 29 does not reduce, so that is my cosine of Z. If we look at this example, we are trying to find sine of A. Sine of A is going to be opposite over hypotenuse. Here's my reference angle A. So my opposite side is the side over here that doesn't touch A. And then my hypotenuse is the side that is across from that right angle. So that's 30. And 24 over 30 does reduce to 12 over 15, which will still reduce to 4 over 5. And so that's my ratio. So those are 3 examples of finding the sine ratio, the cosine ratio, and the tangent ratio. And now we're going to look at how we might use this to find a missing side. Because the ratio for any 2 triangles with the same reference angle, the ratios will be the same, we can use that knowledge to help us find missing sides. So right here, I see that I know this angle right here. So I'm going to go ahead and say that that's my reference angle, is 64 degrees. And so then I'm going to go ahead and figure out what are these other sides that I have labeled here. This side right here is my adjacent side. This side right here is my hypotenuse. So I have adjacent and hypotenuse, and one of my ratios is equal to adjacent over hypotenuse. That ratio is cosine. Cosine is adjacent over hypotenuse. So I can set up this nice little equation that says that cosine of my reference angle, 64 degrees, is equal to adjacent, which is 13, over hypotenuse, which is my x. So now I can work on solving this by multiplying x over to the other side. And I always like to put that x in the front here so that I don't get confused about whether it's on the inside of this cosine. And so then I know that x is being multiplied by that cosine of 64, and I want to get x by itself. So I'm going to divide both sides by cosine of 64. And so I know now that x is going to equal 13 divided by cosine of 64, but I need to do a couple things before I can just type this right into my calculator. I need to make sure that when I hit mode on my calculator and I see this screen, I have to make sure that I'm in degree mode because I'm going to be using 64 degrees as my reference angle. So I need to make sure that degree is selected when I'm in mode. Now, if I've done that, I can go ahead and type in 13 divided by cosine of 64, and I find out that that means that my x is 29.7 when you round to the nearest tenth, as these instructions say. So we are able to find that missing side. So let's do another example. Here we go. We have our reference angle here. We have 65 degrees. And I see that I don't know my hypotenuse, but I do know this opposite side. And I do know this adjacent side. So that opposite over adjacent, that's tangent. So tangent of my reference angle is going to give me opposite over adjacent. And opposite is 17. Adjacent is x. And so we want to solve just like before by multiplying that x to the other side. and then dividing by tangent of 65. And I know that my calculator is still in degree mode because I just put it in there. And so I find out that x is equal to 7.9. And that makes sense because this should be the smallest side length, right? Because this is the smallest angle, so my x value should be smaller than 17, so that does work there. And let's take a look at one more example. So when we look at this one, we see our reference angle here, and I see that I have my opposite side is x, and this is my hypotenuse side, which is 15. And so opposite over hypotenuse is going to be sine, and my reference angle was, oops, I had 65 for my last one. My reference angle is 57. And so to solve this one, I multiply both sides by 15. And I don't have to divide anything. I can just type that right in and find out that my side length is 12.6. So that's a nice review of our work finding the tangent ratio, the cosine ratio, the sine ratio, and how we can use that to find missing sides when we know one side and one angle in a right triangle.